And one more quick thing before he starts. Many of you have sent in your summer camp passports already. Just want to let you know, I've got them. Definitely got them. We're going to start mailing out prizes, your first level of prizes, because there's multiple levels, by the end of this week. So you should get them shortly after the 4th of July. And for anybody else, you can continue filling out your summer camp passports. And if you have any questions, just email me. We'll be able to get you. We want to give you prizes. We want to give you gifts. And one other thing, just a reminder, later today we'll be at the Carnegie Museum, but Friday we'll be at the Franklin Institute. Let's see here. I still have Franklin Institute tickets for you. So we're running a little close now because I have to mail them off. But if you want Franklin Institute tickets, you can email me during the presentation. I'll try to get them off to the mailbox. All right, enough of me. Now to the master teacher, Mr. James. It's all you.
All right, since we had our guest speaker as the Carnegie Museum today, I'm from the Philadelphia area, so I've never visited, but I saw they have a lot about natural history. I thought, well, that relates very well to rocks and fossils. So why don't we take a look at that today? So there's, believe it or not, a difference between the terms rocks and minerals. The definition of a mineral is a solid, crystalline substance with the same composition all throughout. So I have some examples of minerals here. This one I have here is quartz. And quartz is a very strong mineral. You notice it has like these very jagged shapes to it. And when you go to a beach and you see a lot of sand, most of that sand is likely made up of quartz. If I were to take this and grind this up, it would look a lot like sand. One of the interesting things about quartz too is that when you put little other bits of other chemicals, we call impurities in there, it can change some of the features of the quartz. So this here is a bit of rose quartz. It's still quartz. You can see mostly by the same shape, but it has this nice deep purple color to it.
Real quick, I had someone say that they're not getting any sound. Can everyone hear Mr. James? Yes? Okay, people are saying yes. Let's make sure people can hear you. If you're not getting any sound, you might just want to double check your speaker, make sure they're working okay.
All right.
Go ahead. My apologies.
I also have, I think this one, all my minerals might be quartz, but I have this very tiny one too that I believe is quartz as well. And you can see how the crystals kind of grew. And you'll be growing.
Landon actually has some quartz right now. He's showing on camera. If you can.
Oh, you do? Oh, Landon, you have a geode, I believe that is, right? Oh, yes. Thank you for showing that off. So you have some minerals as well. I'm not as good as identifying minerals as I once was, but I can tell at least what kind of rock it is. So quartz is often going to be something that we call a metamorphic rock, where it was heated up and that slowly cools deep underneath the earth and get these large crystals forming as a result. Amethyst, yeah, amethyst has a really nice purple. Landon, I see you got that. Thank you for showing. Here's another one that I'll show. I lost part of it. My cat kicked it off the table somewhere. But this here is bismuth. And when bismuth cools very slowly, you can see it forms these very almost like staircase-like shape to it. And it's also very rainbow colored. And bismuth is actually an element on the periodic table. It is, I'm looking at it, number 83. How do I get the rocks? There are certain stores where you can go and buy them, or I buy them online. Some of these rocks I got because I went to a science teacher convention where they were just giving out rocks to share to students. So I'm using them for that purpose. Speaking of rocks, rock is a solid material that is often made up of one or more minerals. So not all rocks are minerals, but all minerals are rocks. So some rocks I have here, this really smooth one, I believe this is a tiny sample of jade, if I remember correctly.
Now, what color is normally a jade rock? Does anybody know what color jade normally is?
I might be mistaken, but I think that's what this is. Yeah, so you can see it's got a lot of green and white marbled in. It's either that or serpentine, I think is the name for it.
Yeah, and someone mentioned serpentine too. Hold on, let me scroll up because
Yeah,
there's a lot of smart people here today. Miguel and Alejandro, I think, mentioned that.
Oh, you also have business. Good.
That's
Another one that I have here is obsidian. This is an obsidian arrowhead that I got at a store somewhere that sold these. And a lot of tribes or either early human tribes or native tribes, when they would craft their bows and arrows, obsidian was a really great material to make arrowheads out of. And the reason is because it's kind of hard to see on camera, but you can get a really sharp edge in an arrowhead when you make it with obsidian, and you just got to bang it against the rock the right way. If you angle your rock right and you know how to do it, what you're doing, you can easily craft an arrowhead, and you can imagine this going right through something when you're hunting. So obsidian is unique because obsidian is what we call a glass, just like the glass you might have a drink out of, where glass is something that cools so quickly, crystals do not have time to form. So this cooled super quickly, and obsidian is when lava gets onto the surface of the earth. And well, you guys have played Minecraft. How do you create obsidian in Minecraft? At least some people play Minecraft, right? Water and lava. And the reason for that is because you have to have this lava to start with, but the water cools it super, super quickly. And that's how you get obsidian. It has to be cooled very quickly. That's why you have water and lava are going to create that effect. Yep, exactly. How strong is obsidian in real life? It is fairly strong. It's about as strong as like it's glass, so probably about as strong as a glass you have at home. You can break it, but you can also like take it and like try and bend it, and it's going to have some resistance. It's not going to crumble in your hand or anything. It's not the sturdiest material if you need something like super strong, but it's not super weak out of it. All right, and I think that's all the minerals I have to like show off on camera. But you see some minerals I have here on screen as well. We have olivine. Actually, maybe that's what this one is too. It could be olivine too. Pyroxene. Howlite. Howlite is one where if you are a geologist, it is not uncommon if you don't know what a rock is to lick it, which is normally not recommended in science. And I don't recommend you try it overall, but howlite is just salt. If you have table salt that you put in your food, that's howlite. We actually mine that salt. We don't grow salt or have it come from any organism. We mine salt to put on our food. And then there's the muscovite is one that you often use in drywall. And same with biotite will turn into coal over time. So I want to get into how to create crystals, and I need to go and heat up my water for this. But I want to start the process of creating crystals because the process is going to take some time. But here's the steps we're going to do for this. First, we need to heat up some water. So you can use, I said, sugar, salt, or borax. I tried to make some crystals last night with borax, and it did not go well. So I will be making it with salt or sugar today, making some rock candy with you guys. But first, heat up about 1 or 2 cups of water using either a stovetop or a microwave. And of course, work with your parents or learning coaches because you're going to want this water to be very hot, possibly boiling close to it. And the hotter the water is, the better this will work. So you can use a microwave if you don't have access to a stovetop that will also heat water. But I have a teapot on the stove. I just need to turn on for this.
And if you can't do it right now, it's okay. We're going to put it on YouTube. A lot of our stuff is on YouTube, so we'll be able to do it with that too. So I just want to make sure everybody is a little careful as we do this crystal experiment.
Yes, and this one is going to take some time. I'm not going to be able to finish this one for this video session anyways, but I can help get you set up. But the purpose that we want to do with creating some really hot water is that the hotter water is, the more we can dissolve in it. So if we get water very hot, we can dissolve a lot of sugar in it. Actually, we can dissolve more sugar than we have water, and that's what we want to do. We want to dissolve about 2 cups of sugar for every 1 cup of water. So this is going to be a lot of sugar. But then you're going to let that water cool. So I need to step away for 2 seconds and turn on my stove to heat my water. But I'll be back.
While Mr. James is away, does anyone know any other minerals that we might actually eat? You know, we mentioned salt, which is known as sodium. Is there anything else? You guys can type it in. Any other type of minerals we normally might eat in our food or that we might actually put on through seasonings? Silver, we don't eat silver. So there's a few things. So let's say magnesium. Magnesium is something that we normally eat. If you have a banana, they have a mineral in it too. Does anybody know what mineral's in banana? All right, that's potassium. Might have lost some of you guys on this. Oh, there we go, Gabriella. Nice.
Yes.
And
iron is important because every red blood cell you have has iron in it. That's actually what makes it red.
All right, good job, everybody.
So I have my water heating up now. It's a tea kettle, so it'll scream at me when it's ready to go. And I can try and demo the next step. But just to run through our directions, we want to get this water very hot. I like to add some food coloring, make it look nice. And then you're going to mix in about twice as much sugar as you have water. Very carefully. You might get a little sticky because it's sugar, but be very careful with your hot water. Stir very slowly. Don't pour it all in at once. And then when the water, and then you're going to want to let that set aside, let it cool some so that it's not too hot to touch. And then after that's cooled, you're going to put a popsicle stick in there that has been coated with some sugar. And then you'll see those sugar crystals growing on your popsicle stick. So we're going to get back to this. I need to let my hot water heat up some. Yeah, you can do this after class. I'm going to move on to another activity. I have several activities for today. So I saw somebody said they were not prepared to do this right now with hot water, but that is fine because I have some other things that we can do.
And some people mentioned they had some rocks they wanted to show you. Just hold them up to the camera.
Oh yeah, here, let me view the camera here.
Let's see who has, you know, some people
mentioned Melody has a rock. Melody, that looks like
has one. Elise has one too. What one does Elise have? She has 2 of them.
Yeah, Melody, I thought that looked like that green one right here.
And Destiny has a purple rock, it looks like. What kind of rock is that?
Destiny, is that amethyst?
All right. And hold on, I think
Elise has something.
Kobe has a pretty big rock too.
At least that is a large one. That looks like maybe granite. It's hard to tell with the lighting though, at least. There are 3 different ways that rocks can form. They can form from molten lava or magma. We call that igneous rocks. They can form from combining several materials and packing them together. We call that sedimentary rocks. So if you pack together even living things, that will make coal, or pack together sand, that will make sandstone. And then we have another one called metamorphic rocks, where you take one kind of existing rock and you put it under a lot of heat and pressure, and that will change some of the qualities of it. So if you take something like limestone and you put it under intense heat and pressure, normally under the surface of the earth for millions and millions of years, then when it comes back up, it will be marble, which you see a lot of white statues made out of.
And someone asked, could you just go back a couple slides to the, I think what
This
you
one?
had is the directions for the rock, Andy?
Oh, this? Yeah.
Yeah. So just real quick, if someone needed to take a quick picture of that, I mean, you should have got it in your email too. But if you need to take a quick picture, you can go right ahead. Give you a couple seconds. Because we are going to move on to, I believe, let's talk about fossils, and some people kind
Yeah.
of
I do want to get back to this before the end of our session too. But it takes some time to heat up the water, stir sugar in, and then you have to let it cool. So we're going to be kind of moving back and forth to this one. Which is why I wanted to move to fossils. And where did it go? I had a fossil sample somewhere. Oh, is that the one? I had a fossil sample, and I think my cat knocked it off somewhere. All right, I will have to find that later. Unfortunately, I do not have a fossil sample, but you can see what I have sharing on my screen. Fossils are the solidified remains or impression of an organism that is preserved in rock. So most common fossils you see are seashells, because once they settle to the bottom of the ocean, they might get covered in other sediment, and the ocean pressure will pack that into rock. And then you'll see something like this seashell fossil here. Dinosaur fossils are very rare because it takes very specific conditions to form fossils, but we have enough of them that we can see what kind of creatures may have lived millions of years ago. And here's another fossil you see here. Many people believe that fossils are made up of the bones of organisms, and that is not quite true. There's no bones in fossils. Fossils are made up of entirely rock. So the way a fossil forms, you have something, this is an ammonite, and dies and falls to the bottom of the sea, where its body is covered in sediments, protected by being eaten. Oh, Gideon's pulling up a fossil. Here, I'll stop screen sharing for a second so we can see Gideon's fossil. Wow, Gideon, that's a really cool fossil. Oh, Landon, you got a fossil too. That's awesome. Thank you for showing that. And Destiny, looks like you got a fossil there too. Everybody came prepared with their fossils except for me. I had mine sitting out here, and then my cat Dexter was swatting some rocks off of my desk, and I lost some of them. And I had to tell him to get out of my lab.
I don't know, Teacher James. It sounds like you're blaming your cat for not having your homework.
Yeah. Bellamy, is that a fossil too? Nice. All right, well, back to my fossil examples here. So an ammonite dies and falls to the bottom of the ocean of the sea, where it's covered by sediments and protected from being eaten by other animals. And you see the soft parts of the body will decay. So that's another trait of fossils, is only the very hard parts of the body, like bones or teeth, will actually remain. For the next step, more and more sediment covers and is going to squeeze the shell. The shell may remain or be replaced with minerals such as quartz or limestone that seep into the solution before the original shell dissolves. So the original bone or shell will ultimately disappear, but it gets replaced by another mineral. And that is what you actually see when you look at a fossil. There's no bones or shells in fossils, but rather minerals that take the same shape. After millions of years, movement in the Earth's crust may thrust the layer of sediment rock containing the fossil upwards to form part of a mountain range. So weathering and erosion may eventually wear away some of the rock and expose the fossils. Fossils are often found in road cuttings or quartz. So it's not uncommon, because of the dynamics of the Earth, to find a fossil for a creature that once lived under the sea on land or even on top of a mountain. So I saw some people came prepared with a leaf today. And this was another one that I think Dexter knocked off of my desk, but we can create imprints of some small flat objects on paper. And let me move over to my other desk and I can show you how we can do this. So this is something you might see in art class. Let me go back to my camera settings here. Yeah, I'm just taking this mouse with me. All right, so all you need, if you have a leaf, you're going to place that on a table. You're going to put a piece of paper over top of it. I am missing my leaf because somebody knocked things off my desk when I was preparing for them. So I need another small flat object that I can use. Let me see, is there anything that I have over here? A piece of fabric could work too. But a leaf is going to be the best example. I think Dexter ate mine. All right, I have, I can use this dollar bill here. So I'll put that underneath my paper, and then all you need, crayons work best, I find, but you can use colored pencils too. And if you just rub the surface of it, you're going to create an imprint. And you see the out edges of my dollar bill here kind of lining up. And you can create an imprint of your object. You might also have some fabric that I can use too, but anything that is a flat textured surface. So this is the same way that fossils work. This is not a dollar bill, actually. It's really just the outline, because this is not textured enough to really show much of anything, unfortunately. Wish I had my leaf. But we can create an impression of the fossil, and that is what we are ultimately going to see when we look at fossils. It's not the original material, but it is an impression. So I hope some people actually have leaves, and I would like to see your leaves on camera, because I'm sure I see some people have already done this. Oh, and I hear my tea kettle boiling.
And when you get back, Mr. James, just repeat the instructions one more time. I have an idea of, what you're doing here, but I want to make sure. We've had some people who requested it. If you don't have leaves, as you can see, Mr. James kind of went with something else that is flat. So you could use anything that's somewhat flat. I believe he used the dollar bill. Like I have a little notepad,
Right.
use something like that, anything of that nature.
Yeah, I used the dollar bill, and it didn't turn out as great because it's not very textured, but I could try. I don't know, now Dexter's here. You gotta tell me where you took that leaf, bud. Messing up later. I can't hear. And I think a piece of fabric might also work. Trying to look around my office, see if I have anything. Anything great. I have a magnet. I could like try this, but all you need to do, take your whatever object you want to outline, place it underneath your paper, and then you're just going to rub your pencil marker over top of it, and you'll be able to see the outline of it. If I rub hard, now you can see the outline of this magnet that I have in this top corner right here that I have outlined. Works best with leaves, but somebody took mine. So I'm going to let you try it. I'm going to see your results. All right, who has a leaf to show? All right, Gideon, I see you have yours. Elise, yeah, you guys had leaves come out very well. Gabriella, I see a very well-defined leaf that you have there. Looks great. Miguel Alejandro, awesome. Now, of course, fossils are not made out of paper, but they are made out of rock. So I'm going to show you in a bit how to create fossils out of rock. But first, let me go back to my crystal growing experiment because my tea kettle is ready.
And then anybody else do this experiment that wants to show it off, that wants, if you want to show up the camera, what you did with your leaf or anything else to try to make your little fossil, go right ahead and show it off. I'll see who else has done this. You can also take a picture of it and share it with us too, and we'll make sure we put it on our social.
All right, so as you can see, I have a tea kettle that had water, was just boiling. So I'm going to be very careful with this. This is boiling hot. And let's set this. Ooh, that was very hot. It was warping the table. I'm going to put that on the floor. Okay, hold on. Now, I put about 2 cups of water in here. So that means I'm going to need somewhere between 4 to 6 cups of sugar. So this is 1 cup. I should just dissolve right in here. And oh, you know what else I need? A mixing spoon. And also move this tea kettle so I don't trip over hot water.
Nice and great job, William, on your leaf impression that you did. That's awesome.
Sorry, I keep having to run back and forth to my kitchen. All right. Something else I can do is I can add some food coloring and make my rock candy turn out a specific color. I want to keep mixing the sugar in here. That was about ½ cup. I add another ½ cup. One of the incredible things about when you dissolve something in water is that it doesn't take up more space. We're not going to have something like 6 cups of water in here because I add 4 cups of sugar. It will all actually fit in here if it is completely dissolved. Okay, so that's about 1 cup I have added in here. You notice I'm just adding it little bit by little bit. Actually might need to pour some out here. It's getting a little high. Oh gosh, now I cannot fit any more in. There, I need something to touch this. Okay. There we go.
Just make sure we're being very careful with anything that's hot. We don't want to hurt ourselves.
Yeah, that's why I got gloves. So I was realizing I'm not going to be able to add in too much water. So now I can go back to adding sugar. It's just going to be very sticky if you spill anything, but definitely don't spill any hot water on yourself. That's why I had the glove. But since this water is so hot, that allows us to add in a lot of sugar into it. Yeah, I had to pour out some of the water, but be very careful because this glass is super hot for me to touch right now. That's why I had to use gloves. The more sugar you can fit in here, the better this will ultimately work. Just keep stirring it in there, but make sure that the sugar actually dissolves. Once the sugar is no longer dissolving, you got to stop. Okay, so I think I can fit a little bit more in here. Should have picked a larger glass. Now I can tell the sugar is not dissolving as easily. It's kind of getting full again. So let's get that to dissolve.
How's everyone doing? Anyone is doing the experiment? All your sugar is dissolving?
Yeah, it takes a lot of mixing. So that should be enough. Now you need something like a popsicle. You need something like a popsicle stick made out of wood. Get it a little bit wet. And then you're just going to dip that wet popsicle stick in sugar, and you're going to put it in here once it cools. Because if it's hot and you dip it in, the sugar is just going to dissolve. You don't want it to all dissolve right away. So that's why we're going to set this aside and let it cool. Be sure to clean up any mess you have, because it's going to be very sticky with all that sugar. All right. So, oh gosh, I've made quite the mess here. I need to dump out this water because I need this full. So while we are waiting for that to cool, and you can get back to that later, let me show you how to make your own homemade fossils, not just imprints on paper, but some actual fossils that you can use for more three-dimensional objects. I have measured 1 cup of flour. I have a 1/2 cup of salt. And I have 1/4 cup of water. So we are going to make a special kind of dough. And this dough will act like a rock that we can press something in and create a fossil. So I will start by adding in my flour. So this is 1 cup of flour. I have directions for this too that I can share later. You're going to mix your flour and your salt, 1/2 cup of salt. Mix those together first. And I hope you are prepared to get your hands messy for this one. Between the sugar and the flour, today's kind of a messy day. Mix the flour and the salt together. And we have that mixed in, add about 1/4 cup of water. So we are going to mix this, probably start with a spoon. Oh wow, this spoon is sticky. I'm using this much sugar. And then ultimately, because this is dough, you're going to, after you can't really mix it with your hands anymore, or with the spoon anymore, you're just gonna get your hands and you're gonna get right in there. You're gonna get all the flour from the bottom, scoop that up, mix it in. It's gonna be kind of sticky first, but you're gonna get to a nice kind of smooth dough-like consistency. And just keep working at it. If you need to add a little bit more water, you can do that too. I think I gotta stand up for this. All right. I'll start off really flaky texture at first. Just keep working through it.
Can you say real quick just what the measurements were for what they needed for this?
It was 1 cup of flour, ½ cup of salt, and 1/4 cup of water. And I found myself having to add like a sprinkle bit more water after I poured the water in, but not much more. So about 1/4 cup of water. All right. Keep working at it. Feels like a bakery, doesn't it? Yeah, all you guys making dough. This is not something that you want to eat. Not that it has anything unhealthy. It just, we put a lot of salt in here. It just tastes like pure salt. But the salt is going to help it to harden like a rock. What we want to do is we're going to use this as a rock. We're going to create an impression in it. And then, because we have a lot of water and a lot of salt in here, we can get this to dry, get the water out of it. The salt will cause it to solidify and harden. You'll have a nice rock. So I think I'm about done. I'm gonna get up close, hold mine up to the camera. See how this is like nice and smooth now? I can still kind of shape it and knead it. This is about the texture that we want. So from here, you can take pretty much anything. You can take, I have here a coin that I had before. And you can create an impression in your rock, take it out. And then you have a imprint that you can use for a fossil. In fact, if you have one big lump, you can squeeze off tiny lumps. So if you have things like seashells or any toys that you don't have to worry about getting too dirty because this might get stuck in your toy, you can create imprint in it and create your own fossil. So I'm going to step away from it to clean up. I will be right back while you guys keep kneading that. And then you can break it up into several pieces. I'll leave mine right here. I'll be back in 3 seconds.
How much salt did you need again?
½ cup.
½ cup of salt, everybody. All right. It looks like everybody who's still working on this is kind of kneading their dough. That's great.
And I gotta clean up my desk here just a little bit. It's super sugary and sticky.
People are still working on some of their rock crystal, their rock candy stuff too, I see. So that's awesome. I see someone's getting a little professional. They're putting on the gloves. Make sure they're not messy. They're gonna go into fossil surgery. And no, do not bite the flour. That's not good.
All right. Now, I made some of these last night. And these ones have turned into rock. They're pretty solid, except the bottom part is still a little dry, but I can try baking this again.
And
But this
land,
first one I did is I put a Lego minifigure in here. So I got a fossilized Lego character, now entombed in stone. And then I split that off and I made a second one. This one I actually have a skull fossil I can show you in a bit. So I took the teeth of the skull fossil and now I have some fossilized bite marks that I have on the second one.
it almost looks like a baseball.
Oh yeah, I suppose it does. And as much as Dexter has sabotaged me for my experiments today, he did help me create this one here that says, "I heart cats," but with Dexter's paw as a heart. So I like this one. I think I'll keep it. There are two ways you can get this to harden. You can put it in the oven at low. Obviously, have your parents help you. Low for about 2 to 3 hours, and that will get the water out as it heats up. Or you can set it out in the sun to dry for several days. If you just let it sit outside, it's not been the sunniest weather recently, but if we get some sunlight, set it outside. It'll take more time, but you don't have to use an oven. You can get these to dry, and then you have your own fossil imprints of
Dexter,
whatever objects or items you put in there. So you can put like a handprint in there. You can put in a toy. You can put in any object that you want to create. I kind of wrote using a toothpick in here. And I just like pressed in to make the letters. So if you wanted to try something like that, you can write in it. Destiny, I see you have your cat too.
Dexter heard you talking about him. He snuck in from the back.
Yeah, Dexter, here he is. Dexter has been problematic because he loves to be in my office room here and he loves to play with me. And if I'm busy, he will play with other things. And I'm often busy. And those things are often things that I like to do or that I need.
Really quick, does anybody need, I've seen some people ask about instructions and stuff. Did anybody else need us to go over any instructions that we might have missed or anything like that? I want to make sure.
Here's the instructions for the fossils.
There we go. So that's for the fossil. I see many of you are working on it already and are doing a great job. This is awesome. But I see some people are just waiting on the last little bit for the rock candy stuff too, which is great too. Got a lot of experiments going on today.
Right, if I go back to my rock candy, it's still pretty hot. I think it might be cool enough to work with. This last step is the easiest step. I probably filled this a little too high. Be careful not to spill. But you're going to take a popsicle stick for your rock candy. And you're going to coat it in some sugar. I'm just going to stick mine straight in here. And if your water is cool, it's not going to be able to absorb a lot more water. So I have keep dropping things. I'm going to try and hold this in place with these two clips. And if your water is cool enough, mine might still be a little too hot, honestly. I saw a lot of the water dissolve in there, a lot of the sugar dissolve in there. But if it's cool enough, then your popsicle should be able to just hang in there. And then if you let that sit for some time, you'll create crystals, rock candy. You'll see crystals forming. Yeah. Now, this is not something you will be able to eat tomorrow or the next day or probably this week. It takes, I've read, at least like 5 days for sugar crystals to fully grow in this solution. So it's going to take some time, but just have some patience. If you use sugar, then you should be able to just eat it right off your popsicle stick. So today we went through how to make rock candy. I had you create some impressions on paper for fossils, and I had you create your own dough to make your own rock fossils. Does anybody want to go through any instructions or anything I can help with for these? Or is there cats in the chat? Because there's cats in my office, they keep invading. The rock candy instructions, yeah. So it is about 1 cup to 2 cups of sugar. You're going to want some hot water. And then once you mix in the sugar, then you need to let the water cool. So it takes a little bit of time in between every step because you gotta let water heat up and then cool again. But the cat learns how to use the chat box. Yeah, if you use sugar to create your rock candy, your sugar crystals, then yes, you can eat those. You saw I put in some food dye too, so it looks pretty fun to eat. Otherwise, you'll just have white crystals. Nate, it looks like you have your dough really well made, prepared to go. That looks like a good texture. Mine, right back here. I can probably make some more fossils. I'm trying to think of what I can make fossils of. Maybe I could do another paw print. Also, if you break this dough up into tiny pieces, it's going to harden and solidify quicker. Dinosaur toys. Oh my gosh, that's so genius. Why didn't I think of that? We will often see fossilized footprints because, as you can imagine, the footprint will like step down in mud and then that mud will harden and then you get a nice big fossil from it. This is also just like really fun and nice to knead. It's like slime, but not as messy. I do have a little Nintendo amiibo for one of the characters here. I would try that if I wasn't worried about getting dough stuck in some crevice there. Are there any other questions? I kind of ran through all my material kind of quickly today, so we ran with a little bit more time, but if you're still making your fossils, you can work through that. I see some people still working with their dough. Miguel, if yours is too sticky, like it shouldn't be too sticky, I'm just using my bare hands, I'm not getting much of my hands. You can add a little bit more flour and that will help make it more doughy if you added too much water. You might have to wash your hands afterwards regardless. I don't have a lot of amiibos.
All right, guys, any other questions about either activity? Are we going to go back to mention anything about the rock candy experiment before we jump into something else?
No, the only thing I had was once it cools, coat your popsicle stick in sugar, like get a little wet, dip it in sugar, and then suspend it in your sugar solution. And then if you leave it there for several days, you should see some crystals grow. It'll take some time to grow though. You probably won't see it after the first day. And I mentioned borax too, because borax is not something you can eat, but borax crystals grow really quickly and they grow a lot more crystals compared to sugar. So I was trying to set something up where I could show off some borax crystals, but things did not go right yesterday with that. When I was trying to prep it, I broke a glass. It was not fun. So I'm just skipping the borax crystals. You're welcome. When you melt candy and add it to the rock candy, I don't know. It depends what kind of candy. The thing with the sugar in that solution, the sugar is not melted. The sugar is dissolved, and that's a key difference there. The reason why we heat the water is not to melt the sugar, is because liquids are able to hold more dissolved stuff called solutes when they're at very high temperatures.
So I got a question for you. Gabrielle mentioned about melting candy and adding it to your rock candy, and I'm assuming it's because you want it to be a certain flavor. Is there anything else that you've done? Has anybody here done any sort of baking, made cupcakes or cake where they wanted it to make a certain flavor? Put in chat if you have. No one's made a cake before? I see. Okay, some people have they're a little messy. Okay, so if you take certain things, they're usually called extracts, vanilla, orange, lemon. You could add that after the sugar dissolves to try to make your rock candy a certain flavor if you wanted to. That's a fun way you could do that.
Yeah, so something like vanilla or orange extract would change the flavor of it. You can try and dissolve other candies in your water solution too, might change the flavor. A lot of candies are able to dissolve in water.
All right, guys. Well, it's 10:55. You guys can continue working on your fossils if you want. What we're going to do is we're going to take a little break here, and I am going to stop the recording real quick.